In this segment, I'll describe different characteristics of IT life cycles and methods used to create and deliver software products and services. Now, a project life cycle is a series of stages that a work effort passes through from the point of initiation through closure. This is different than a product life cycle, which usually has 5 stages. The project life cycle can be part of one or more phases in the product life cycle. For example, a project's life cycle could be used to create the first stages of a product's life cycle, for example, development. Also, a product could be enhanced with a project life cycle, or a product could be taken out of service and put into retirement using a project life cycle. So there is a difference between actual project life cycle, which can be thought of as kind of the vehicle used to deliver a product or service, and then the product life cycle, which is the life of that actual product or service. Now, there's 3 main life cycles we see in IT, and they can be classified as either predictive, iterative, or adaptive. Adaptive is also known as agile. There are differences between how the work is carried out between these approaches, and that's what we're going to talk about. This table shows a general high-level view between more traditional and agile approaches. Of course, the column on the left shows the traditional areas of a project or program and what the purpose is of each. Of course, the column on the right shows the agile approach and what typically happens in that area. Now, please note, these aren't exact one-for-one mappings, but should help bridge your thinking about how traditional and agile approaches differ in terms of delivering value. You see some similarities there, but there's clearly differences. So now let's take a detailed look at those differences between more predictive stage gate methods, iterative, and adaptive approaches used by organizations to deliver products and services. In traditional approaches, the IT life cycle's sequential and non-iterative. That's very important, sequential and non-iterative, where work flows downwards, and hence the name waterfall. For example, in a waterfall method, we'd start with defining scope. So once the requirements are confirmed, a design phase would be completed. After design finishes, development would start. And after development, maybe a test phase would be conducted. And finally, the product or service would be deployed to production in a single Big Bang release. Now, iterative or incremental development, on the other hand, is a method to produce a system through repeated cycles called iterations. Again, what's important to note here is that in iterative development, we go through repeated cycles. Now, these cycles are used to create software in slices known as increments. Little bits of functionality is delivered over time in increments. Now, you can think of it as a way of decomposing a large application set of requirements into smaller chunks or features. And these chunks of features are delivered over time through iterations. So in iterative development, these features are, again, designed, they're developed, they're tested in repeated cycles, and at the end of each cycle, that slice of functionality is released. Now, with adaptive approaches, a software product is delivered within a time-boxed iteration. That time-boxed iteration can also be known as a sprint. So at the end of every sprint or iteration, again, there's an increment of value which is potentially shippable. And that's really important to note. That little bit of value could potentially be shipped. In other words, it could be launched, it could be deployed to production. And those potentially shippable increments are known as PSIs, or again, potentially shippable increments. So just like in traditional approaches, requirements are still present. There's design, there's development, there's testing, there's deployment. However, each of these activities are completed within that small time box, and that time box may be only 2 to 4 weeks, as opposed to months or years. So as a result, value is delivered in increments as opposed to delivering all the value at once at the end of the effort, which again, in some cases could take a long period of time, months or years. So customers get to experience working software early and often instead of all at the end of the project. What's also important to note, all the requirements of such a large product or service may not be known up front, right? We all know of stories that customers may not know exactly what they want, just like you and I may not know exactly what we want when we're trying to define something very complex. So instead of trying to define everything up front and really struggle to get the details, why not develop something in increments? So now we have an opportunity to use these more adaptive approaches. Instead of defining all the requirements up front, we have a way of dealing with those in smaller increments or smaller iterations. Of course, change can also be a bit more challenging as the cost of change increases significantly when moving from paper to production and or to the market. So in this particular example, if you want to make a change on a piece of paper, it may take a designer a very short period of time to change something on paper. Once that product or service is in production, that cost of change really increases, and you can see that in the cost curve. So in very small efforts, like this difference may not be that noticeable, but in large term efforts, those differences are very noticeable. There are key differences between highly predictive and highly adaptive approaches as well. For example, life cycles. In a predictive life cycle, it's very plan-driven. Upfront, documentation, focus on the plan, get the details in place. Adaptive, it's more change-driven. So with predictive methods, requirements are defined upfront, and the team will deploy one increment of software at the end of the project. Again, could be months or years later. With adaptive models, requirements are progressively elaborated, and the team will deploy small increments of working software early and often, and more so can inspect and adapt more frequently. Again, back to that more traditional approach, at the end of a phase or a project, the team may have a lessons learned or retrospective to figure out what worked and what didn't work, and can adapt for the next phase or the next project. Of course, in adaptive models, you're going through that cycle every 2 to 4 weeks. So there's a lot more frequency in terms of inspecting and adapting, a lot higher chance to improve quality, reduce risk, lower cost. So in predictive development, a stage or phase usually starts out after the completion of the previous stage. Of course, using adaptive models, the planning continues at that consistent rhythm throughout the life cycle. Now, regarding execution of delivery, again, in predictive models, the team will usually deploy one increment of software at the end of the project. Could be months or years. They will inspect and adapt at the end of the project or phase. And in adaptive models, the team will deploy small increments of product more frequently. 2 to 4 week time boxes are usually the norm. They will inspect and adapt within each time box. So a well-designed agile process flattens the cost curve of change, as we described before. The agile process is about incremental delivery over time, enabling teams to adapt to changing requirements without that increased cost of change from predictive models. When incremental delivery is fused with paired programming, continuous delivery, automated testing and deployment, the risks of higher costs associated with change are reduced due to the preventative measures that are built into more agile processes from the start. So in this segment, we reviewed different characteristics of IT life cycles and methods used to create and deliver software products and services. By now, those differences between predictive, iterative, and adaptive life cycles should be much clearer, as well as the difference between a project life cycle and a product life cycle.